Now, how do I simplify log 0.125 to base 64? Now, the first thing you want to do is to convert this 0.125 to a proper fraction. So 0.125 is equal to 125 over 1000. And when you reduce this to the lowest term, it's going to be 1 over 8. So I can rewrite all of this as log 1 over 8 to base 64. Now, the next thing to do is to rewrite 1 over 8 and 64 in their index form. So I know that 8 ordinarily is equal to 2 raised to the power 3, and 64, being 8 times 8, is 2 raised to the power 3 multiplied by 2 raised to the power 3, and that's 2 raised to the power 6. That means multiplying 2 with itself repeatedly 6 times will give you 64. Now, but what I have here is not just 8, it's 1 over 8. So that 1 over, there's a law of indices that says that when you have 1 over a raised to the power n, it's going to be a raised to the power minus n. That's 1 over will become a negative power. So if it is 2 raised to the power 3, 1 over 8 will become 2 raised to the power minus 3. So now what I'm going to do is I will replace 1 over 8 and 64 with their index form. So this is going to be log 1 over 8 is now 2 raised to the power minus 3, and 64 is now 2 raised to the power 6. Now there is a law of indices. There's a law of logarithm. Now I'm going to write the laws very quickly now. Now, 2 laws actually that I want to write. It's just a single law, but I'd like to write it in 2 forms so that you can get and understand properly. Now, there's a law like this. If I have a log of a raised to the power n to base x, for instance, this law says that this power here can become a coefficient of the logarithm, and it's going to be n log a to base x. So this power here becomes the coefficient. Now, what if I have the log and I have a power in the base and not in the number like this? Something like this. Log of a to base x raised to the power m. I'm using m so that you not get confused about this. Now, what do you do when the power is in the base? So the result is going to be similar. The only difference is that when you are bringing a power from the base as a coefficient, you are bringing the inverse of that power. So it will be 1 over m log a to base x. So note the difference. When the power is in the number, it just comes behind the log ordinarily. But when the power is in the base, so you have to introduce an inverse notation here. So it's going to be 1 over m. No. So how do I apply this here? Now I can start with the number. That means 2 raised to the power minus 3. So according to the first law I have written, it's going to be minus 3 log 2, then 2 raised to the power 6. So what I've done is I brought the power of 2, which is the number here. I brought it behind according to this law right here. Now, but I still have a power of the base. So how do I do that? This is the same thing as saying minus 3. Now I'm bringing this also to the same spot where I have minus 3. So I'm going to have to multiply it. I'll say times 1 over 6. Now this 1 over is as a result of this law that I've written here. Then I'm going to have log 2 to base 2. So now what happens when I have the log of a number to a base and the number and the base are equal? As in I have log a to base a. You can say that the number and the base are equal. So what do I do at this point? So according to this law of logarithm, when the number and the base are the same thing, then your result is going to be 1. The result is going to be 1. So this log 2 base 2 now is going to be equal to 1. So I can write all of this as minus 3 times 1 over 6 times 1. Since log 2 base 2 is now 1. Then I know that 3 here 1, 3 here 2. So I'm just going to multiply. 1 times 1 times 1 is 1. There's a negative sign, so minus 1 all over 2, and this is my answer.